Okay, so here we are with a few extra problems for section 7.6 that we went over in class, or if you have any questions or just kind of forgotten or missed the day. So first of all, we are trying to determine for 1 and 2 if this is if these dilations are enlargements or reductions, and we went from A to B. So here's the thing to remember, that A is the original, then B is the new. Okay, and the scale factor is new to original. So for number 1, hopefully by looking at it, it's kind of obvious. Hey, A is the small guy down here. B is the bigger one right here. So what that means is it got bigger. This is an enlargement. Okay, this got larger. So enlargement. Now, scale factor for that, we just have to find two sides that correspond, and the easiest two are really the horizontal ones here. So B's length is 1, 2, 3, 4, 5, 6, 7, 8. A's length is 1, 2, 3, 4. So 8 over 4, which becomes then 2. Okay, so there's the scale factor. It's 2, and it's enlargement. Plus, since the scale factor is bigger than 1, we also knew it was an enlargement. Looking at problem number 2, same exact idea. New over old. Obviously, this time, B has gotten smaller than A was, so the new length is smaller than the old length. Okay, so that means it's reduction. Okay, so now I'll compare new length, which doesn't matter what you choose, but this is pretty easy to see. It's 2. So scale factor is 2, and the old length is 4, which reduces to 1/2. And that's another way to check too. Reductions get smaller and their scale factors are less than 1. Enlargements get bigger, their scale factor is bigger than 1. So there's 1 and 2. And that's the kind of general problem for the section. Okay. Last type of problem. Verifying if something is an enlargement or reduction. So, number 12 of the book, Jordan is putting a photo of the lacrosse team in a full-page layout in the yearbook. The original photo is 4 by 6 inches. Okay, so here's original length, 4 by 6. If the photo in the yearbook is 6 2/3 by 10 inches, is it a dilation? Original photo. If so, what's the scale factor? So what we have to show is that, okay, it did get bigger, so it would be an enlargement, but did it get bigger proportionally? Now, there are two ways to go about this. You could say, okay, well, let's see. 4 corresponds to 6 2/3. 6 corresponds to 10 because it's smaller and smaller, bigger and bigger. That's one way. So just compare them. So 4 to 6 2/3. Now the problem with that, you can see, is that this is a whole number, this is a mixed number. What you could do is you can make it an improper fraction. So 6 times 3 is 18. 18 plus 2 is 20. So we have 4 over 20 over 3. And then multiply both those by 3, canceling off that 3. That gives you 12 over 20. That reduces to, divided both by 4, 3/5. Okay, so that's the first comparison between the 4 and the 6 2/3. Now I'll compare the 6 and the 10, which reduces to 3/5 because 6 and 10 are both divisible by 2. So is this a dilation? Yes. Scale factor is 3 to 5. Sorry, strike that. Scale factor new to that, I wasn't paying attention. Blue is the original. Sorry, 4 and 6 are the original. 6 2/3 and the 10 are the new. So actually, this isn't the scale factor. That's just the ratio from from old to new. Scale factor flips that. It's 5 to 3, which it needed to be bigger than 1 because it's an enlargement. Another way to verify that this was an enlargement or not is just to set up 4 to 6 equals 6 2/3 and 10. And then when you cross multiply, you'll get 40 for this one. And 6 2/3 times 6 also gives you 40. So you could show their cross product is the same. So there's a couple different ways to verify it. The problem with this is it doesn't give you the scale factor. So then it's say, oh, well, the new length was 10. the old length was 6, reduces to 5/3. Okay, so there we go. Those are the extra prompts from section 7.6.